Okay, dear students, we will continue with exercise 3.4, question 2, sub-question 3. Now, these kind of sums, that is two-digit number sums, are very, very important. You get such sums in exercise also, and such sums are also in illustration. Let us understand what is the question. The sum of the digits of a two-digit number is 9. Two-digit number like 63, 54, 26, all these are two-digit numbers. Now, whenever you are having two-digit numbers, you have studied in earlier standard that one digit is at tens place and the second digit is at unit place. So, in short, there are two digits over here. One digit will be at tens place, another digit will be at unit place. Now, the sum of those two digits is equal to 9. So, the first condition is that the sum of the digits of a two-digit number is 9. That is my condition number 1. Second condition, also 9 times this number, 9 times the original number is twice the number obtained by reversing the order of the digits. Means if I make 27 as a number, then if I reverse the digits, it becomes 72. If I have 45 as a number, if I reverse the digit, it becomes 54. So, be very, very clear. Two conditions over here. First condition, the sum of the two digits of two-digit number is 9, and 9 times the number, that is your original number, is twice the number obtained by reversing the order of the digits. In short, I need to find the number. So, dear friends, whenever you get this kind of sum, these four lines will be common. The four lines that you see, or whenever there is any question in this chapter which deals with a two-digit number, then these four lines will be common. Now, as there is a two-digit number, one digit will be at tens place and other digit will be at unit place. So, I will suppose that the number at tens place is x and the number at unit place is y. So, now the number will be represented as 10x plus y. Why 10x plus y? Because the digit at x is at tens place. Suppose the value of x is 5 and value of y is 4, then the number will be 10 into 5, that is 50 plus 4, that is 54. So, always as this digit is at tens place, it is represented as 10x, unit means 1. So, y ones are 1, so you no need to mention 1 over here. So, the original number will be always represented as 10x plus y. Now, in second condition, we are reversing the order of the digits. So, when I reverse the order, 10x plus y becomes 10y plus x. So, dear students, again, whenever you are asked any question which is based on two-digit numbers, these four lines will come. Let the number at tens place be x, let the number at unit place be y, let the original number be 10x plus y, and the number obtained by reversing or interchanging the digits is 10y plus x. Now we will move to the condition. What is our first condition? The sum of the digits of a two-digit number is 9. So, what are the two digits? One digit is x, another digit is y. Their sum is 9. So, first equation becomes very, very simple. That is x plus y is equal to 9. That is my equation number 1 based on condition number 1. Now, understand the condition 2 properly. 9 times the number. Now, digits are not mentioned. What is mentioned? Number. Number is represented as 10x plus y. So, 9 times the number. Be very careful. 9 times the number. So, 9 into what is number? 10x plus y is represented as is equal to twice the number obtained by reversing the digits. So, twice means 2. Number obtained by reversing the digit. What is the number obtained by reversing the digit? 10y plus x. So, 2 into 10y plus x. So, once again, 9 times the number. 9 times the number. So, 9 into 10x plus y is twice the number obtained by interchanging or reversing the digits. So, 2 into 10y plus x. Now, we open the brackets. So, 10 into 9, that is 90x plus 9 into y is 9y is equal to 2 into 10y, that is 20y, plus 2 into x, that is 2x. Now, in this particular method, we always have x and y on the left hand side of equation and the constant term on the right hand side of equation. Now there is no constant term, so I will take all the x and y on the left hand side. So here I am having 90x. When I take these 2x on the left hand side, 90x minus 2x will give me 88x minus. Here I am having plus 9y. When I take 20y on the left hand side, so 9y minus 20y will give me 11y is equal to 0. Now to make this equation a little bit smaller, you can see that 11 is common in this term. So I will divide all the terms with 11. So 88x becomes 8x, 11y becomes y, 0 divided by 11 remains 0. So the second equation is 8x minus y is equal to 0. Now as we already found out all two conditions in equations, so now the solving of sum becomes very easy. What are our two equations? According to condition number 1, our first equation is x plus y is equal to 9 and the second equation is 8x minus y is equal to 0. I wrote both these equations over here. Now as you can see that coefficient of y is same, but the sign is opposite, so no need to change the sign. So I can directly carry out the elimination. So plus y and minus y got eliminated. X plus 8x, that is 9x, and 9 plus 0 is 9. So I got value of 9x as 9. That means the value of x is 1. Now I will put this value of x in equation number 1. What was equation number 1? X plus y is equal to 9. But the value of x is 1. So 1 plus y is equal to 9. That means value of y is 9 minus 1, that is 8. Again, many enthusiast students will consider that the sum is over here, but sum is not over. You are asked to find the original number, and the original number is represented as 10x plus 1. So 10 into what is the value of x? The value of x is 1. So 10 into 1 plus y. What is value of y? 8. So 10 ones are 10 plus 8. That means the original number is 18. Okay, now the next question. Meena wants to withdraw 2000 rupees from a bank. She asked cashier to give her rupees 50 and 100 notes only. So Meena wants to withdraw a total amount of 2000 rupees. She goes to the bank and requests the cashier to give her only rupees 50 and rupees 100 notes. Meena got 25 notes in all. So when the cashier gave her 2000 rupees in the form of rupees 50 notes and rupees 100 notes, she got in total how many notes? 25 notes. Among these 25 notes, some notes will have denomination of 100 rupees and other notes will have denomination of 50 rupees. So total there are 25 notes. How many? We need to find that how many are 50 rupees notes and how many are 100 rupees notes. Clear? So once again I repeat, understand the question. Meena wants to withdraw a total amount of 2000 rupees, but she wants that 2000 rupees only in the form of 50 rupees notes and 100 rupees notes. Now, when the cashier gives her that amount, she gets 25 notes in all. Using this data, we need to find that how many are 50 rupees notes and how many are 100 rupees notes. So we need to find two things: how many 50 rupees notes, how many 100 rupees notes. So we will take the number of 50 rupees notes as x and number of 100 rupees notes as 1. So once again, what is our supposition? Let the number of 50 rupees notes be x and let the number of 100 rupees notes be 1. Now the first condition, she got 25 notes in all. That means the total of 50 rupees notes and the total of 100 rupees notes. When you add up, she should get a total of 25 notes. So what is the number of 50 rupees notes? That is x plus what is the number of 100 rupees notes? That is y. So my first condition will be x plus y is equal to 25. That means the number of 50 rupees notes plus the number of 100 rupees notes is 25. That is my condition number 1. Now when you look at the sum, you will think that okay, the sum is over. How to get condition number 2? Condition number 2 lies in the total value. The total value is how many rupees? 2000. So the total value of notes is rupees 2000. So Meena is having x notes of 50 rupees. X notes of 50 rupees. So 50 into x plus she is having Y notes of 100 rupees. So 100 into 1. So when you add up the total amount, the total value of these notes should be equal to 2000. Once again, Meena has total notes 25. So X plus Y is 25. Now that X notes are of 50 rupees. So X into 50, that is 50X. She has Y notes of 100 rupees. So 100 into Y, and the total value is 2000. Now again, to make this question simpler, I can see here that 50 is common in all the three terms. So I have divided all the three terms by 50. So 50x became 1x, that is x. 100y became 2y, and 2000 became 40. So now we are having the two equations. Equation number 1 is x plus y is equal to 25, and the second equation is x plus 2y is equal to 40. Now something is very simple. X plus y is equal to 25, x plus 2y is equal to 40. You can clearly see over here that the coefficient of x are same, but the sign is same. So here I will just change the sign in the second condition. So this plus x became minus x, plus y became minus 2y, and plus 40 became minus 40. So this x minus x, the x part got eliminated. Y minus 2y. I have subtracted 2y from 1y, so I will get minus y is equal to 25 minus 40 gives me minus 15. So minus y is minus 15. That means y is 15. After getting the value of y, I will put that value either equation 1 or 2. I put that value of y in equation 1. What was equation number 1? X plus y is equal to 25. So x plus, what is value of y? 15. So x plus 15 is equal to 25. That means x is equal to 10. Now, number of 50 rupees notes was supposed to be x. So value of x is 10. So total number of 50 rupees notes is 10. What is y? Rupees 100 notes. So 100 rupees notes, y is 15. So is equal to 50. So you can verify whether your answer is correct or not. Okay? Simple logic. See. 10 plus 15. Total number of notes is 25. Now multiply. 10 notes of 50 rupees. So 10 into 50, that is 500 rupees. And 15 notes of 100 rupees, that is 1500. 1500 plus 500 gives 2000. So we can be very sure that our sum is perfectly